Hey guys, in this video, we are going to start with the basic models, which are the basis for starting with LLMs. Now, to understand the large language models, we have to have a basic idea about what are the uh, attention networks, what are the transformer, what are sequential models, and where does it start from. So, in this video, we are going to discuss about attention. So what is attention? So attention networks are nothing. Uh, they the idea behind attention is to give attention to a particular sentence. Let's take an example of machine translation, and then we will come to what attention is. Machine translation. Like many examples for sequence to sequence models, we have machine translation. We have maybe sentiment analysis. We have uh, many more applications for the production of, for the understanding of basically the sequences. Sequences in terms of text. So we are going to talk about text only and what are the sequences, what are the applications, and with this, I'll pick this machine translation. Now, how does this machine translation go? Machine translation is when I have a sentence in Hindi, यह एक किताब है, and I want to convert it into English. This is a book. Now you can see that multiple words are occurring in a different places. Like is occurring on the second place, and hai is occurring on the fourth place in Hindi. So this is machine translation. Basically, we want to convert Hindi into English using machine. Okay. So what exactly we want to do is we want to translate the sentence such that it generates whatever is needed. So before understanding the machine translation, let's go back to our oldest networks for sequential models. So for sequential models, we have multiple networks. We have multiple deep learning models. First one is RNN, second one is GRU, and third is LSTMs. I've already explained these models in my previous videos. I'll give link to you if you want to get into depth of these. So what does these models do? They have they take input sequences. This is a book. So they take each and every word at a time step T1, T2, T3, and T4. So at different time steps, these models are trained and their output is passed to next layer like this. Okay, and so on. So as you can see here, you then you have the second layer and so on. Then you have the third layer and so on. Now, if it's because in machine translation you saw that is can occur anywhere in the different language. This is input and in output this place of is can be anywhere. So to for the systems like the machine translation applications like machine translation, they generated a new model called seek to seek model. This model is encoder decoder based model. This is based on encoder decoder. Okay, so let's discuss briefly what does this seek to seek model do, so that you get an idea of background idea before understanding the attention. Okay, so let's start. So let's say we have the sentence, this is a book. What seek to seek does is it applies LSTM model or maybe RNN or GRU as it is, and whatever the output of this model is, it will pass to encoder. Okay, so encoder would have information from this, from this, from this. So past information from all the words is uh, represented in, is represented in encoder. So encoder has intermediate representation, right? So encoder has intermediate representation. What does it do is it passes that information to decoder. It will go to decoder, and decoder will generate yah, first word. Then yah is passed to second word, it will generate ek, and so on. Okay, so this is the decoder part, and this is the encoder. Okay, so this model is called seek to seek model. This whole model is called seek to seek model. So what are the disadvantages you can see? So to generate this intermediate representation, the seek to seek model have information of all these words, but highest information would be of book, less information of this word, then lesser information of this is, and then even lesser information for this. So as the sentence length keep on increasing, only the last word is significant, and this first word becomes least significant. Its value reduces because it's just a number. Number is getting computed and it's getting passed to the next state. So for first, suppose it was passing zero point 0.1 to next state, it will zero point 0.1 cross zero point 0.1. So and as so on. So up till now, if it reaches over in the fourth state, so the value of first word is lost, somewhat reduced. So as long as if you have a longer input sequence, it would not retain the effectiveness of first word or the initial words in the sentence. So this was a disadvantage with the seek to seek. Now, sorry. So now to reduce this disadvantage, new model came, which is called attention. Now, what does attention do? Let's see. Let's say my sentence was, book is of red color and it is big. Book is big. So it corresponds to big, right? It corresponds to book. So the weightage of book should be high, right? So what does attention do? Attention takes all these words as input to the encoder. Okay. All these words are taken as input to the encoder, and weights are given to each and every word. So book will be given high weightage when it is calculating it. Okay. So weights of each and every word is calculated. Let's say let's look how does this tension work. Let's say this is a sentence. This is a book. Now, our goal is to give weightage to several words, like is cannot be given more weightage, other words can be given more weightage than is, right? So what does it do is it will make a weighted sum for all these things which are passed as uh, decoder input. Okay, let's look. How does this work? So all the hidden states generated by this one, H2, H3. Hidden state is nothing, it's just the output, or you can say the calculations inside the cell, LSTM cell. If you want to know more about it, you can go to LSTM video. Now, all these inputs are passed 1, 2, 3, and 4 into a vector, and this vector is called context vector. Okay, and suppose it was h1, h2, h3, and h4. Now each and every number is multiplied by a weight, and all these are added, and a new vector is generated. This is called context vector actually. This is called context vector. The context vector is nothing, it's just the weighted sum of these inputs. Now we can decide that h1 is to be given more weightage or less weightage. It is can be given less weightage. It can be given more weightage. Book can be given even more weightage. Okay. So these weights. Now these weights are basically W1, W2, W3, and W4 are calculating using softmax function. You know that softmax function range is between 0 to 1. If you add all these numbers, it will be 1. So these are all probabilities. So let's say I give 0.1 to first one, I will give 0.2 to second one, 0.6 to third one. So fourth one should be 0.1. So sum of all these weights should be 1. So it's like a softmax function. So all these weights are calculated like this. Okay. Now, after the context vector is generated, this context vector is passed where? It's passed into decoder, right? So it will be this context vector is passed to the decoder, and decoder was having nothing like seed number. Before this we generally keep a starting symbol SOS as the input, and as output also SOS. It's a starting symbol which says that okay, sentence is starting. So first word would be generated taking this and this, these two things as input. So first word would be generated yeah. Now this yah is passed to next word and so on. So this is how attention works. Also, there's one more thing. To decide the second word, this first word is also used to decide these weights. How these weights are calculated is dependent upon the first input word. So it will decide that my next input word is how much uh, dependent on which one of the input words. Okay. So to calculate the math, to understand the maths behind it, I'll make a new video to understand the maths behind attention. So this is all the basic concept of attention is. Thank you so much.